Hi everyone, and welcome to the week 1 video where we're looking at the review preview for section 4.1 chapter 4 in our CPM book. We're going to start with solving the following equations. A says 10 is equal to the square root of x. So this says that if we took the square root of a number, that would equal to 10. So the way we solve this problem is by squaring both sides to get rid of that square root. 10 squared, 10 times 10 is 100. And then that is just, and then the squared here cancels out the square root, so we're just left with x. And that is our answer. And if you think about it, if we were to take the square, plug 100 in here, and we took the square root of 100, that would equal to 10. So that checks out. All right, let's go ahead and go to the next question, where we've got the square root of x minus 4 is equal to 3. So something to be careful of here is the square root is covering this entire x minus 4. So to cancel that, we do need to square both sides. Okay. When we do that, the square root cancels out, and we're left with x minus 4 is equal to 3 squared, which is 3 times 3, that is 9. Now we can go ahead and add 4 to both sides. So that cancels, and 9 plus 4 is 13. Okay, looking at part C, so same idea here. We have the square root of x plus 2 is equal to 6. I'm going to go ahead and square both sides to get rid of the square root. So we've got x plus 2 is equal to 6. Going to subtract 2 on both sides here. So x is equal to, oh, I'm sorry, my fault. Did you guys catch my mistake? I forgot to square the 6. So 6 squared is 36, my fault. Sorry. And then I'm going to go ahead and subtract the 2. So x is equal to 34. All right, so let's go ahead and look at D. So we've got 10 times the square root of 9x is equal to 60. So we do want to get rid of the square root, but notice how with the other questions, the square root was really the only thing on its side of the equals. Now we've got this 10, so we actually do need to get the square root by itself before we start doing that squaring step. So what I'm going to do is divide by 10 on each side first. Okay, so when I do that, I'm left with the square root of 9x equals 60 divided by 10, which is 6. Then I'll go ahead and square both sides. So now the square root goes away, and we're left with 9x is equal to 6 squared, which is 36. We can divide by 9 on each side, so that cancels. And we are left with x is equal to 36 divided by 9, which is 4. Okay, letter E, get that isolated. So what we're going to do is we're going to work on what's being added or subtracted first, and then we'll deal with the multiplication division, okay? So I'm going to go ahead and subtract by 7 on each side. Remember, we're trying to isolate that square root. So that leaves me with negative 3 times the square root of 2x minus 5 equals negative 8 minus 7 is negative 15. Then I'll divide by negative 3. So I'm left with the square root of 2x minus 5 is equal to negative 15 divided by 3 is 5. Now the square root's been isolated, so we are ready to square both sides. So we are left with 2x minus 5 is equal to 5 squared, which is 25. I'll add 5 to both sides. So we're left with 2x equals 30. Divide by 2 on each side. 30 divided by 2 is 15. Okay, so now let's go ahead and look at this next one. So it says solve the following equations, and you must check all solutions to make sure each one works in the problem. All right, so what we're going to do here So we've got the square root of 5 minus x, and then minus 1 equals x. So let's go ahead and start with adding 1 to both sides. And we've got the square root of 5 minus x equals x plus 1. All right, now we're ready to square both sides. Okay, but now we're left with 5 minus x is equal to x plus 1 squared. Okay, well, x plus 1 squared, that's x plus 1 times x plus 1. Okay, so we are going to have to multiply that, so I'll do that over here. We've got x and 1 and x and 1. We've got x squared, 1x, and 1. So that's equal to x squared plus 1x plus 1x plus 1. So that's x squared plus 2x plus 1. So we've got 5 minus x equals x squared plus 2x plus 1. We are going to set this equal to 0 because this is a quadratic here. So I'm going to take, we're going to subtract 5 on each side. And at the same time here, I'm going to add x. So these cancel, and we're left with x squared plus 3x, and 1 minus 5 is a negative 4. Okay. Now, let's make our double parentheses. What multiplies to be negative 4 but adds or subtracts to be 3? So when I think about my factors of 4, we're going to split up our x's. You know, if we've got a negative 4 or a positive 4 and we subtract 1, 4 minus 1 gives us 3, and 4 times negative 1 gives us negative 4. We split them up, so x plus 4 is equal to 0, and x minus 1 is equal to 0. I'll subtract 4, so x is equal to negative 4. I'll add 1 to each side, so x is equal to 1. All right, and it does say to check the answers. So let's go ahead and we'll plug them in. So we're going to do our check. So let's check x equals negative 4, and we'll check x equals 1. So the square root of 5 minus a negative 4 minus 1, is that equal to negative 4? Okay, so that becomes 5 plus 4, which is 9, and then minus 1 equals negative 4. The square root of 9 is 3, and so that would be 2 equals negative 4, so no. So that solution, we usually use the term extraneous here, but it doesn't say to label it that way necessarily, but it does say you must check the solutions to make sure each one works. So this one does not work. And then I need a little more room here for x equals 1. So we've got the square root of 5 minus 1, and then minus 1 equals positive 1. 5 minus 1, that's the square root of 4. Square root of 4 is 2. 2 minus 1 is 1, so 1 does equal 1. So this solution does check out. So let's look at the next one. All right, so let's go ahead and square both sides right away. So we've got x plus 7 is equal to, and then this becomes x plus 5 times x plus 5. Okay. To the side here, we can do our box method. So that's x squared, 5x, and 25. So that's equal to x squared plus 5x plus 5x plus 25, which is equal to 10x plus 25. So we've got x plus 7 equals x squared plus 10x plus 25. I'll go ahead and subtract 7 on both sides, and at the same time here, I might as well just subtract the x. So we've got 0 equals x squared plus 9x plus 18. Now I'll do our double parentheses. So what multiplies to be 18 but adds or subtracts to be 9? So our factors of 18, we have 1 and 18, 2 and 9, 3 and 6. Well, We've got 6 plus 3 is 9, and 6 times 3 is 18, so I think those check out. We'll split them up. X plus 6 equals 0, and x plus 3 equals 0. Subtract 6 on both sides, so x here is negative 6 and negative 3. So let's go ahead and do our check. So I'll start with x equals negative 6. So we've got the square root of negative 6 plus 7 equals negative 6 plus 5. Negative 6 plus 7 is 1, and negative 6 plus 5 is negative 1. The square root of 1 is 1, and that is not equal to negative 1. Now let's try x equals negative 3. Let me do a little highlight here so you guys can see where I separate them. So that gives me the square root of negative 3 plus 7 equals negative 3 plus 5. Negative 3 plus 7 is 4, and negative 3 plus 5 is 2. The square root of 4 is 2, so 2 does equal 2. So that solution does check out. All right, so this question here says you need to find the point of intersection for the lines y equals 18x minus 30 and y equals 22x plus 50. Explain how you would find the point of intersection, and what is the point of intersection? So I think we could do a graph. And we could use Desmos. Okay. So let's go ahead and take a look at those. So we have y equals 18x plus 30, or minus 30. Okay, and then we also had y equals negative 22x plus 50. Okay, and so when I look here, I see that we do have our intersection at 2, 6. All right, so here's how I'm going to write that out. I'm going to write down both of the equations. And oops, I'm going to use a different color. Okay, so I'm going to make a graph here, and I'm just going to make a rough sketch of it just so you've got it here, of the graph. So the blue one, so we did have our point of intersection was at 2, 6. Okay, so y equals 18x minus 30. That graph kind of looks like, that line kind of looked like this. And y equals negative 22x plus 50. That one kind of looked like, I got it, I promise. Like this. At 2, 6 here. So that was our point of intersection. Okay, and then I'm going to write that out. The point of intersection is 2, 6. Okay, and then our next questions are asking us to solve the system using any method, graphing, substitution, or elimination. So I'll do one with substitution, maybe a couple with elimination, and then one graphing, okay? So let's start with this one, and let's do the substitution method. So I'm just going to write that here for you. Okay, and with the substitution method, one of the things that I like to do first, so I like to think of it as steps, and one of those steps is to isolate the variables. So when I'm looking at this, like if I look at this equation or this one, is there a variable, either the x or y, that looks easy to get by itself? Sometimes I look for that. And I see this y wouldn't be very difficult to get by itself. So if I've got 4x, if I just subtract 4x on both sides, I'm left with y equals, and then I'm going to write negative 4x minus 2. Okay, so I did that. Now that tells me that this is what y is equal to. So my next step here is I'm going to plug that into the other equation. So I've got 3x plus 2y equals 11. So this is what y is equal to. So I'm going to put that here. Okay. So this becomes 3x plus 2 times negative 4x minus 2 equals 11. I distribute. So I've got 3x plus negative 8x minus 4 equals 11. Okay, 3 minus 8, that would be a negative 5x minus 4 equals 11. I'm going to add 4 to each side. So negative 5x equals 15. Divide by negative 5, so x equals negative 3. Okay, then for my last step, what we do is we can take the isolated variable that equation that we found, and I'm going to plug in negative 3 for x. So that's going to go here. So y equals negative 4 times negative 3 minus 2. So that becomes 12 minus 2, which is 10. Okay, so we have our answer. X is equal to negative 3 and y is 10. All right, let's do the elimination method. For part B. So we've got 2x minus 3y equals 8 and 4x plus 5y equals negative 10. So what I like to do, so when we write these out, I'm going to write it out. So what we're doing is we're looking for a way to change it, basically. So how can we change one of these equations so if we were to add them, one of the variables would cancel out? So because this is a negative 4, if I were to change this 2 to be a 4, then when I add them together, it'll cancel, and I can solve for y. So I'm going to times this entire equation by 2. So when I do that, I have 4x minus 6y equals 16, and then I'll leave the bottom one the same. Okay. Now when I add them together, these cancel. 4 minus 4 is 0. And negative 6 plus 5 is a negative 1y. And 16 minus 10, that would give us 6. Divide by negative 1. So y is equal to negative 6. Okay, so now I'm going to go ahead and plug that in to one of the original equations. So I'm going to take, let's do 2x minus 3y equals 8. Well, now I know what y is. Y is negative 6, so I'm going to plug that in. So we've got 2x minus 3 times negative 6 equals 8. So that'll be plus 18 equals 8. Minus 18 on both sides. Just making sure I did that correctly. Yep, so then we've got negative 10, divide by 2, so x is equal to negative 5. We have our answers. Okay, let's look at this one. How about we do the elimination method one more time? Maybe? Yeah, we could do elimination method one more time. Then we'll do graphing for the last one. So again, I like to write them out. Okay. I see if I multiply this bottom one here, if I multiply this all by a 2, then I can get these 4's here to, then this will become a negative 4 and then x can cancel. So I'm going to rewrite it. So I'm going to leave the top line alone. So I've got negative 4x plus 10y equals negative 18. Interesting. You guys see when I add these all together, do you see how everything cancels? Interesting. So what that means is that 0 equals 0. This means that they are the same line, which means there are infinite solutions. Okay, and then the last one, let's do the graphing method. Okay, so what I'm going to do for graphing is I'm going to type them both into Desmos. All right, so we've got 4x minus 3y equals 8 and negative 8x plus 6y equals 16. And negative 8x plus 6y equals 16. Okay. Oh, interesting. So do you guys see how there is no intersection with these lines? I see their intercepts, but they're parallel. They just keep going and going. There's no point where they intersect. So that tells me that there are no solutions because there's no intersection. And that's what we've been looking for this whole time. So just to sketch this out really quick, just going to sketch it out. So we had one that crossed here, and then we had one that crossed like right here. And again, this is no intersection, so no solution. Okay, and that completes our video. Thanks everyone for watching. Have a good day.